Our next topic is refraction through a rectangular glass slab. So for doing this, for starting this topic, we need a drawing board, a rectangular glass slab, white paper sheet, 4 pins. So let us start this. For doing this, first of all, we have to place a white sheet. We have to fix a white sheet on a drawing board, wooden drawing board. So with the help of drawing pins, we can fix the white sheet on a wooden drawing board. Then after fixing the white sheet, we have to place the glass slab. We have to place the glass slab in the middle of that drawing sheet or a plain paper sheet. We have to put a glass slab on it. Then we have to make an outline A, B, C, D. We have to draw an outline of this glass slab. So after drawing the outline of the glass slab, then we have to take 4 pins. First of all, 2 pins we put on this side. We fix 2 pins on this side such as E and F at 2 points E and F. Fix 2 pins on this side. Then looking at the image of these pins from this side, this is our glass slab which is fixed on a white plain sheet of paper. This is A, B, C, D is a glass slab, and we have fixed 2 pins E and F on this side. And looking at the image of these pins from this side, we have to fix other 2 pins G and H on this side. Looking at the image of these 2 pins in such a way that E, F, G, H, they all should be in a straight line. So we have fixed 2 pins here, and looking at the image of these 2 pins, we have to fix 2 pins here, G and H, in such a way that they all should be in a straight line. Then we can remove this glass slab. We can remove this glass slab as well as we can remove these pins also. After removing the pin, join these 2 points E and F and make a line here. Same way, we have to join these 2 points G and H. But when we remove the glass slab, we can find that E, F, G, H, these 4 points are not in a single line. They are not in a straight line. But when the glass slab was here, we have used these pins G and H as if they are the images of E and F. Means they were in a straight line. But when we remove the glass slab, we find that these G and H pins, or we can say these 2 points, they are not in a straight line. It means this is our instant ray. So this is our instant ray and this is our glass slab. So when the instant ray passes from one medium to another medium, this medium is air. This is our air medium. This is our glass slab, which is our second medium. And here we are again having air, which is our third medium. So light ray is passing from air to glass slab and glass slab to air. Okay. And this is our instant ray, which is entering from air to glass slab. Air is a rarer medium and glass slab is a denser medium as compared to air. So when light ray is entering from air to glass slab, the speed of light gets changed. We know that the speed of light is maximum in vacuum. That is 3 into 10 to the power 8 meters per second. It is maximum. And we consider same in air also, because there is a marginal difference, but we consider 3 into 10 to the power 8 in air also. This is the speed of light. And this is maximum in vacuum or air. So speed of light is maximum here. So when the light ray enters from air to glass, from this medium to this medium, its speed slows down. Its speed slows down because the medium is denser. It is coming from rarer medium to denser medium. So its speed slows down. And when we draw a normal at the point of incidence, this is the point of incidence. When we draw a normal here, like this, when we draw a normal at this point, same way we can draw a normal here also at the interface of these 2 mediums. We can draw normal here at the interface of these two mediums. So this is a normal. We can have O dash, or we can have N dash. We can use any letters here. This is a normal at the interface of air to glass slab. This AB is the interface of these two mediums, and our CD is the interface of these two mediums. Okay, so this is normal O and O dash, and this ray is incident ray. This is our angle of incidence. This is our angle of incidence, and this is our angle of refraction. Angle of refraction. This ray is incident ray, and this ray is refracted ray, and this ray is our emergent ray. Incident ray, refracted ray, and then our emergent ray. Incident ray, refracted ray, and emergent ray. So, this is incident ray, refracted ray, and emergent ray. And this is angle of incidence, this is angle of refraction. Same way, for when the light ray passes from glass slab to air, then this becomes the incident ray. This ray becomes our incident ray, and this is our refracted ray. Okay, this is incident ray, and this becomes our refracted ray. We can put this, this is N dash, suppose this is M, and this is, we can put any letter here. Suppose P. We have already used. Okay, so our EM is incident ray, MP is our refracted ray, and PH is our emergent ray. Okay, for this is angle of incidence, this is angle of refraction. For this interface, this is our incident ray, and here we are having angle of incidence, and here we are having angle of refraction. This is angle of incidence, this is angle of refraction. So when a light ray passes from rarer medium to denser medium, when the light ray passes from rarer medium to denser medium, it bends towards the normal. Bending of light is refraction. When a light ray passes from one medium to another medium, it changes its direction of propagation. It changes its direction of propagation, or it bends. So this bending is refraction. So when light ray passes from air to glass slab, it bends towards the normal. This is our normal. So this is our light ray, and it should be in this direction. If it passes straight, if it goes in a straight line, then it should pass like this, but it has bent in this way, so it bends towards the normal. So when light ray passes from rarer medium to denser medium, it bends towards the normal. And at this interface, when the light ray passes from denser medium to rarer medium, this is denser medium and air is a rarer medium as compared to this. So when light ray passes from denser medium to rarer medium, it bends away from the normal. This is our incident ray. This is our incident ray, and it should pass in this direction. But now it has bent away from the normal. This is our normal, and it has bent away from the normal. So when the light ray passes from rarer to denser medium, it bends towards the normal, and when it passes from denser to rarer medium, it bends away from the normal. And its bending at the two interfaces is equal and opposite. Bending at these two interfaces is equal and opposite. And when we extend this incident ray, it will be parallel to the emergent ray. When we extend this incident ray, this is our incident ray, it will be parallel to our emergent ray. It will be parallel to our emergent ray. This is incident ray, it will be parallel to our emergent ray. This GH is our emergent ray. So this is incident ray, this is refracted ray, this is emergent ray. This is angle of incidence, this is angle of refraction, this is angle of incidence, this is angle of refraction for this interface. So when the light ray passes from rarer to denser medium, it bends towards the normal. And when the light ray passes from denser to rarer medium, it bends away from the normal. Okay, and this is all because of the speed of light. Speed of light is maximum in air, and which is a rarest medium. So when the light passes from rarer to denser medium, its speed gets slows down and it bends towards the normal. And when the light ray passes from denser to rarer medium, its speed gets faster or increases, and so it bends away from the normal. So this is all about our refraction through a glass slab.